The top 10th birth of a monster, how hurricanes form. Ever wonder how a seemingly calm tropical breeze can evolve into one of nature's most powerful forces? Let's dive deep into the mysterious and fascinating process behind the formation of hurricanes, nature's colossal storms that leave a path of destruction but also showcase the intricate dynamics of our planet. Number 1. The warm ocean waters, the perfect starting point. Hurricanes are the ultimate expression of tropical power, and they owe their birth to the warm waters of the ocean. But why does the water temperature need to be at least 80 degrees for a hurricane to form? The answer lies in the ocean's ability to store and release vast amounts of heat. Warm water acts like a massive energy reservoir, heating the air directly above it. As the air warms, it becomes less dense and rises, much like a hot air balloon. This rising air leaves behind an area of low pressure at the ocean's surface. And that's where things get interesting. Air from surrounding areas rushes in to fill the gap, but because the ocean continues to supply warmth, this process doesn't stop. The hotter the water, the more energy the storm has to feed off, setting the stage for a larger, more intense hurricane. But it's not just the warmth, it's also the moisture. The ocean's evaporation rates increase with temperature, adding more water vapor to the atmosphere, which becomes the fuel for storm development. Number 2. Humid air and low pressure, the invisible trigger. Warm air rising from the ocean isn't just warm, it's also humid, filled with moisture evaporated from the sea surface. This moisture is the key ingredient for hurricane formation. As this warm, moist air rises higher into the atmosphere, it begins to cool. And when warm, moist air cools, the water vapor condenses into tiny droplets, forming clouds. But here's where the magic happens. When water vapor condenses, it releases latent heat, a hidden source of energy. This latent heat release acts like gasoline on a fire, causing the air to warm even more, which triggers more air to rise, continuing the cycle. This creates an area of even lower pressure at the surface, drawing more air inward from the surrounding area. The difference in pressure between the storm's center and its surroundings becomes more pronounced, and the system starts to take shape. But low pressure alone doesn't make a hurricane. You need the perfect blend of rising moist air, low wind shear, and the Earth's rotation to kick things into gear. Number 3. The Coriolis effect, nature's spin. This is where things get fascinating. The Coriolis effect, caused by Earth's rotation, plays a crucial role in giving hurricanes their distinctive spin. Without the Coriolis effect, all that warm, rising air would simply move straight up, and the storm would lack the organized, swirling structure we see in hurricanes. So, what is the Coriolis effect? As the Earth rotates, different points on its surface move at different speeds. Points near the equator travel faster than points near the poles, because the Earth is wider at the equator. This difference in speed causes moving air to deflect. Air rushing toward the low-pressure center of a storm doesn't move in a straight line, but is instead bent into a curve. In the northern hemisphere, this causes hurricanes to rotate counterclockwise, while in the southern hemisphere, they rotate clockwise. Without this spin, the storm wouldn't be able to develop its powerful, rotating structure. The Coriolis effect is stronger closer to the poles and weaker near the equator, which is why hurricanes don't typically form at the equator itself, despite the warm water. Number 4. Tropical disturbances, the seeds of a storm. Before a hurricane becomes a hurricane, it begins life as a simple tropical disturbance. This is often just a collection of disorganized thunderstorms over a patch of warm ocean water. However, this seemingly chaotic jumble of clouds has the potential to grow into something much more dangerous. Tropical disturbances can form in several ways, but most commonly, they emerge from easterly waves, which are disturbances in the trade winds that blow across the tropical Atlantic. These waves create areas of low pressure where warm air can rise, triggering thunderstorms. Not all disturbances will develop into hurricanes, Most of them fizzle out before they can become organized. For a tropical disturbance to grow, it needs to be over warm water, have plenty of moist air, and exist in an environment with low wind shear, that is, minimal variation in wind speed and direction at different altitudes. Too much wind shear can tear a developing storm apart before it gets the chance to organize. Number 5. Tropical depression, a developing system. When a tropical disturbance begins to organize and rotate, it can strengthen into a tropical depression. This is the first official stage of tropical cyclone development, where winds are still relatively weak, less than 39 miles per hour, but the storm starts to develop a distinct circulation. In a tropical depression, the air is rising in the center, and the storm's overall structure becomes more coherent. You may start to see a more defined center of low pressure, but it's still not a fully developed system. However, the stage is set for more rapid development if the conditions remain favorable. Tropical depressions are tracked by meteorologists, as they have the potential to become much stronger. At this point, it's like watching an embryo develop. The storm is still in its infancy, but under the right conditions, it could grow into a powerful hurricane. Number 6. The birth of a tropical storm. Winds start to roar. When the winds of a tropical depression strengthen to 39 to 73 miles per hour, the storm is upgraded to a tropical storm. This is when things get serious. The storm now has a stronger rotation, and it starts to develop the beginnings of its spiral structure. At this stage, the storm is also given a name, a system devised to make communication and warnings about dangerous storms easier. But the tropical storm isn't just about wind, it's also about rainfall. Tropical storms are capable of producing torrential rains that can cause flooding well before the winds become hurricane strength. The storm is now fully rotating, and if it remains over warm water and encounters favorable conditions, it can grow into a hurricane. During the tropical storm phase, meteorologists keep a close eye on the system, as many tropical storms can intensify quickly. The race is on. Will the storm fizzle out or grow into a monster? Number 7. Hurricane formation, the eye of the storm. Once the winds exceed 74 miles per hour, the tropical storm has officially become a hurricane. Now, the storm starts to display one of the most iconic features of hurricanes, the eye. The eye is a small, calm area in the center of the hurricane, where winds are light and skies are often clear. The eye forms because the rising air in the hurricane's core descends slightly in the center, creating this calm zone. Surrounding the eye is the eyewall, a ring of towering thunderstorms that houses the most intense winds and rain of the storm. This is the most dangerous part of a hurricane, with wind speeds often exceeding 150 miles per hour in stronger storms. The contrast between the calm eye and the ferocious winds of the eyewall is one of the most striking features of a hurricane. At this stage, the storm is fully organized, with a tight, well-defined circulation. Hurricanes can vary greatly in size, with some spanning hundreds of miles across, while others remain relatively compact. Regardless of size, the hurricane is now a fully developed force of nature, ready to unleash its fury. Number 8. Intensification, strength in the right conditions. Hurricanes have different categories based on their wind speeds, but not all storms stop at Category 1. When conditions are perfect, warm ocean water, low wind shear, and high humidity, a hurricane can undergo rapid intensification. This is when wind speeds increase dramatically within a short period, sometimes jumping from a Category 1 to a Category 4 or 5 in just hours. Rapid intensification occurs because the storm is feeding off the ocean's heat and using it to fuel its growth. The deeper the warm water, meaning heat isn't just at the surface but extends downward, the more energy the storm has to draw from. This allows the hurricane to intensify quickly, sometimes surprising those in its path. Hurricanes that undergo rapid intensification often make landfall as major hurricanes, Category 3, 4, or 5, capable of causing catastrophic damage. Meteorologists use advanced models and satellite data to predict intensification, but it can still happen unpredictably, leaving little time for preparation. Number 9. The destructive force, winds, rain, and storm surge. At its peak, a hurricane is an awesome and terrifying force of nature. It brings three main dangers. Hurricanes generate sustained winds that can exceed 157 miles per hour in a Category 5 storm. These winds are strong enough to rip roofs off houses, uproot trees, and turn debris into deadly projectiles. The stronger the hurricane, the more widespread the wind damage will be. Hurricanes aren't just windstorms, they're also major rainmakers. These storms can drop several feet of rain over a short period, leading to flash flooding and river flooding. Even after the winds die down, the rain can persist, causing long-lasting damage far inland. One of the most dangerous aspects of a hurricane is its storm surge, a wall of water pushed on shore by the hurricane's winds. Storm surge can raise sea levels by several feet, inundating coastal areas and causing widespread flooding. It's often the deadliest part of a hurricane, especially in low-lying areas where water can rush in quickly. Number 10. Landfall and dissipation. The end of the journey. A hurricane's life often ends when it makes landfall. When a hurricane moves onto land, it loses access to the warm ocean waters that have been its energy source. Without this heat, the storm begins to weaken, and its winds gradually die down. However, just because the hurricane is weakening doesn't mean it's no longer dangerous. Even after the winds slow, hurricanes can continue to drop torrential rain, causing deadly flooding. And storm surges can cause devastation long after the storm itself has weakened. Some hurricanes, like Hurricane Harvey in 2017, dump record-breaking amounts of rain over large areas, causing catastrophic flooding. Hurricanes are a breathtaking display of Earth's power, both beautiful and terrifying. Their formation is a delicate balance of ocean temperatures, atmospheric conditions, and the Earth's rotation. These massive storms remind us of the intricate relationships that govern our planet and how small shifts in nature can lead to monumental outcomes. So next time you see a storm brewing, take a moment to appreciate the journey it's on. From warm ocean waters to swirling powerhouse, hurricanes are true wonders of our world. Once the hurricane dissipates, the cleanup and recovery efforts begin, but the memories of the storm's destructive power often last for years. Don't forget to like, share, and subscribe for more cool stories like this. Let us know what you'd like to see next in the comments. Thanks for being awesome.